Hi, I'm Andrew Linhart, and I'd like to briefly talk about our circuit that we'll be using in the ADIPS project, particularly for dispensing the acrylic fluid. So there are a few major components here that we'll be using, one being the Arduino Uno to act as the overall brains of the circuit, the A4988 stepper motor driver module, which is the interface between the stepper motor and the Arduino, and the pinouts and details are up here. And then finally, the stepper motor itself, which will act to control the plungers. So the overall circuit should be rather simple. We've got a main motor supply coming in here, 12 volt, with this capacitor here to smooth out the supply, and that comes in here, powers the module. And then these four wires go in for the two phases of the stepper motor. The logic supply comes directly from the Arduino, and then the step and direction inputs are coming from some digital output pins from the Arduino. And then these buttons here, we've got some more inputs coming in here, and then the rest of it, they're all tied to ground. So basically, you press the button, pulls it low, Arduino sees that, and then we will program sequences based on which button is pressed. So what I'm thinking would be this button here could be a single dispense. Press it, and it runs however many steps it needs to for that whatever current setting it's on. This button here can cycle the number of steps, so in effect change the amount of acrylic actually dispensed. And then the final button here would be a refill sequence. So the Arduino, we could have it track or keep count of how many forward step pulses it's actually sent out. And whenever this button is pressed, it'll flip the direction of the Arduino, send that many forward steps, basically that number of steps back into it. It pulls the plungers back up, and then it can flip the direction back around so that it's ready for dispensing again. So overall, should be fairly simple. Some things may change, like we'll probably want to have a way to actually display how or what the current step size or how much fluid is being dispensed. That would be a nice addition here. So uh, overall, fairly simple, straightforward. Hope you were able to understand, or I was able to explain it simply enough. Thank you.
Hi, I'm Thomas Malone, and I'm going to talk a little bit about what's going to happen after the circuit that Andrew just described. So to convert the rotational motion of the stepper motor to linear motion, the output shaft of the motor will be rigged up to a lead screw as the one shown, and that will turn through a nut which will allow the edge of it to advance forward in linear fashion, and that will contact a wooden plank which is directly connected to the plungers of the syringes we plan to use, and this is what will advance it down to dispense the fluid. The syringes themselves will be secured in a wooden housing of its own, and the top plank will also be able to be removed to allow the plungers to be removed for refilling of acrylic fluid.
Hello, I'm David Hargraves, and I'll be briefly covering the two major types of testing we'll do next semester. First type of testing is design verification testing. Main point here, we don't want to run too deep with the flawed design. We want to test it as it'll work in the lab and identify any weaknesses early on and correct them. Second phase of testing will be test and fix. Main purpose here is to push the design further than it would be in the lab, identify weaknesses, maybe dispense more fluid at a faster rate, see where it'll fail, and identify possible sources of failure.
All right, so moving forward, there are a lot of obstacles that we need to figure out. One of them is the programming aspect of the project, which is, pretty important because the machine isn't going to dispense dendrites or do anything without the actual program. So while we all have some basic programming knowledge, none of us really have any experience working with the Arduino software, which is basically an open source software slash hardware platform that designs microcontrollers. So we definitely have some learning to do over the break to figure out how the Arduino software works and how to build the actual code so that the machine functions how we want it to.